Okay, so this is the review for our group quiz that we're going to take on tomorrow. So the very first two problems are two of your most favorite problems that we've done, our special right triangles. And the way that we did them was that we made our list 30, 60, 90, and our formulas for the 30-degree angle, that's x radical 3, and 2x. And it's not a bad habit to also label the actual sides. This is 30, so this is x radical 3. I'm sorry, let me fix that. This is 30, so this side would be your x, and this is opposite the 60-degree angle, so this would be x radical 3. So now, the next thing we do is fill in for the side whose length we know, and that is the side opposite the right angle, which would be the 90-degree angle, so I can put a 6 here. So students, this is what I need you to understand. Whatever's in this box is equal to what's in this box. And so that means I can write an equation. My equation is 2x equals 6. So I have to solve that for x by dividing both sides by 2. X is equal to 3. So that means back over here, wherever I have an x is 3. So this x is equal to 3. This x that's in front of the radical 3 is also equal to 3. And I am done. The second problem here is a 45, 45, 90 triangle. So let's start off with writing out our angles. They're both 45 degrees. That means it's an isosceles right triangle. And then I'm going to fill this in. This would be x, and this would also be x. This is x radical 2. That is something you really need to know. So this is x, this is x, and this is x radical 2. So which side actually has a measurement given? Well, this leg here is x. It doesn't matter where you put it. Both of these are going to be 4. And so since x equals 4, that means wherever I see an x, I can replace it with a 4. So x radical 2 becomes 4 radical 2, and we're done. Now you're probably saying these two problems were easier than some of the problems we've done, and you're right. And so I'll make a separate video, perhaps tomorrow, that involves solving some of the more difficult ones, okay? Now, this says find the value of the trig ratio. Remember, a ratio looks like a fraction, okay? Now, if we wanted you to write it as a decimal, we would tell you to write it as a decimal to the nearest 10,000th. But it says write the ratio, so we just want to write the ratio and reduce it down to its simplest terms. So it says the sine of x. I don't need the angle measure. I'm not looking for the angle measure. It didn't tell you to find the angle measure. So just because you can, don't do it unless you're being asked to do it. So here's angle x, and I know that the sine function, I'm just abbreviating, equals to the length of the opposite side divided by the length of the hypotenuse. So I am here. The side across from me, the side I cannot touch, is the side that has a length of 15. So the sine of x equals 15 over the hypotenuse, and the hypotenuse is 39. And then always check once you get to this point and see if you can reduce it. And this indeed does reduce by 3, and that gives us 15 divided by 3 is 5, 39 divided by 3 is 13. So that is what we're looking for. You can leave it right there unless it says give it as a decimal, and remember we want that to the nearest 10,000th decimal place. That's 4 decimal places to the right of the decimal point. So let's look at number 4. So I see it's asking for the cosine of C, and cosine is equal to the length of the adjacent side over the hypotenuse. And so the cosine of C equals, so here's C, so you're standing here. So we need the adjacent side and the hypotenuse. Well, remember the right angle points to the hypotenuse, and the opposite side is the one you cannot touch, so this must be the adjacent side. So the cosine of C is going to equal 30 over 34. Can I reduce that? Sure can. Now remember, if you're not good at reducing, you can always start by just dividing by 2's or dividing by 3's or whatever. So like if I try dividing by 2's, then that would give me 15 over 17, which is my final answer. 17 is prime, so I can't break that down anymore. Moving right along, we have this last one, the tangent of A. So tangent equals, oops, tangent of the angle equals opposite over adjacent. So the tangent of A is going to equal the length of the opposite side. So remember, the opposite side is the side you can't touch. It's across from. So this side here is across from, so that's the opposite side. This is the hypotenuse, the 20, but I don't need that. I need the adjacent side, which is 12. So it's going to be 16 over 12, and 16 over 12, both the 16 and the 12 reduced by 4. So that leaves me with 4 over 3. And your tangents will often be improper fractions. Your sines and cosines will never be an improper fraction, but your tangent can easily be an improper fraction, depending on the triangle. Number 6, it says, find the missing side. Please read and pay attention to what you're looking for. Now, if you're looking for a missing side, you have 2 options, but the option you have to use depends on the information that's given. So the first thing I'm going to try to use is the Pythagorean theorem, but that only works if I know 2 side lengths of my triangle. As you can see here, you only know 1 side length, but you know an angle, which is fine because we can use a trig function to do that. Sorry about that, I keep getting some interruptions, but let's keep it moving. So this is a case where I have to use a trig function. There's no way I can use the Pythagorean theorem because I only have 1 piece of information. Pythagorean theorem requires 2. So now I have to figure out, well, which trig function am I going to use? Well, don't just stare at it. Okay, start working the problem. It'll start talking to you. So here's your angle. If you're standing here, then what would this side be relative to that angle, our reference angle? Well, it's the side you can't touch, so that's the opposite side. The right angle points to the hypotenuse. So then, remember, you should always write SOHCAHTOA out on your paper. Should have done that earlier, but better late than never. So I'm looking over here, and I'm looking for the relationship that involves the opposite side and the hypotenuse, and so that would be the sine. So I would say the sine of 63 degrees equals the length of the opposite side divided by the length of the hypotenuse. And hopefully you remember, I repeat this every day, if x is on the top, you're going to multiply. If x is on the bottom, you're going to divide. Okay, so that's just a little hint, a little trick that we use. And so here x is on the bottom, so I should say switch and divide, because we're going to exchange these 2. They're going to exchange positions, so you're going to end up with x equals 16 divided by the sine of 63 degrees. And you type it in just like that, in that same order. Whatever's on top is what gets typed in first, students, okay? 16 divided by the sine of 63 degrees. And it told us to round it to the nearest tenth. That's 1 decimal place to the right of the decimal point. So it goes from 17.957, and that's going to end up rounding up to 18.0, because Uh, then if I start at the 9, that's one decimal place. I look to the right of 9, I have a 5, which is 5 or higher, tells me I'm going to add 1 to 9. When I add 1 to 9, it kicks it up to 10. I have to carry, I end up with 18, okay? So that's the nearest 10th, 18.0. Let's take a look at number 7. So for number 7, once again, I'm looking for missing length. And so I'm standing here relative to standing right here. I cannot touch this side. It's the opposite side. This side right here is the hypotenuse, but I don't need that side. This side will be the adjacent side, which is a tangent function. So I'm going to say the tangent of 61 degrees is equals to the measurement of the opposite side divided by the length of the adjacent side. Once again, x is on the bottom. We're going to switch and divide. So x is going to equal 15 divided by the tangent of 61 degrees. So I pick up my handy dandy calculator. 15 divided by the tangent of 61 degrees. And I got 8.31, which would just round to 8.3. Now, if I look at number 8 and 9, I shouldn't be confused. We've been doing these since the beginning of the school year, guys, okay? Come on now. I need you to work with, well, okay, I lied. I didn't look carefully enough. These are the new ones, okay? So I made a mistake. These are not Pythagorean theorem problems. Well, let's just go ahead and talk about that. Okay, so I have a triangle here. I know two sides. I'm missing the third, but this goes to looking at the question. It says find the measure of the indicated angle. So this is my unknown here. So, how do I do those? I have to use the inverse trig function. Remember in our notes we say that we set them up just like regular trig functions, but we solve them using inverse trig functions. So here's my angle relative to this angle. This is going to be the opposite side. This is going to be the hypotenuse. And so which trig function involves the opposite side and the hypotenuse? Well, that would be the sine. The sine of x equals the length of the opposite side divided by the length of the hypotenuse. And so since I'm looking for the missing angle, so you know that because the unknown is on the left-hand side of the equal sign, it's going to become s equals the inverse sine. So you're going to use that second key of 27 over 31. So I'm going to go second sine 27 divided by 31, and I end up with 60.57, which now for angles we usually round angles to the nearest whole number, so that would be 61 degrees. Okay, moving right along. Number 10. Number 10 is asking us to find a missing side length. And oh, guess what, guys? Another special right triangle. Now, it's set to leave your answer as a radical. That is a pretty good hint that you're going to use a special right triangle. Honestly and truly, you can solve special right triangles using trig functions. And when I was a student, sometimes just to double check myself, because as you are, I sometimes did not like doing special right triangles when I was a student. And so I liked the fact that I could do a trig function as a way to check my answer. And you can always convert radicals to decimals using a calculator. So let's go ahead and tackle this one. So I have my 30, 60, 90 here. 30, 60, 90. So I'm making my table. Okay. And then I have my formulas memorized. Okay. And it's I would recommend, it's not required, that you label your triangle as well. The 30-degree angle is going to be across from the shortest leg, and then the 60-degree angle is across from the longer leg, so x radical 3. Alright, so now, so that means which one do I have a value for? Oh, x radical 3, 2 radical 3. Okay, oh, this is a nice one. Okay, so the reason I say it's a nice one is because I have x radical 3, and then I have 2 radical 3. These are equivalent. X, let's move this up a little bit. X times the square root of 3 is equal to 2 times the square root of 3. I hope you can look at this and see that x must be 2. Alright, x equals 2. And so I can put a 2 here, and then this x is 2, so 2x means 2 times 2, which is 4. So that's that. And then I have my 45, 45, 90. So let's go ahead. Practice makes perfect. Repetition causes information to be permanent. So this is x, this is x, this is x radical 2. And so this would be x, this would be x, this would be x radical 2. And for which side do we have a measurement? We have a measurement for one of the legs, so it doesn't matter where I put it. I'm going to put it here. 3 radical 2, all of that over 2. Remember, whatever's here must equal what's down here. So x equals 3 radical 2 over 2. So this is also 3 radical 2 over 2. This one right here, this x, is 3 radical 2 over 2. So I'm going to replace that x with 3 radical 2 over 2. And it's being multiplied times the radical 2. Alright? So, let's work it out. 3 radical 2 over 2 times radical 2. If you want, you can put that over 1. Doesn't matter. So this is going to be, now remember, radical 2 times radical 2 times radical 2 is radical 4, which equals 2. Okay? So this is the square root of 4, which equals 2. So this is really 3 times 2 over 2, which is 6 over 2, which is equal to 3. So that is equal to 3. Number 12 is not a special right triangle because 63 is not one of our categories. It's not a 30, 60, 90, nor is it a 45, 45, 90. So let's go ahead and work it out. Relative to where this angle is, the side you cannot touch is the opposite side. So this is the opposite side. The side across from the right angle is the hypotenuse. So once again, we see our friend the sine function. So we're going to say the sine of 63 degrees equals the length of the opposite side over the length of the hypotenuse. And, I don't know why I wrote an extra 0 on there. Let's fix that. X over 20. And x is on the top, so I multiply. So x equals 20 times the sine of 63 degrees. So I type it in the calculator just like that. 20 times the sine of 63 degrees. So x equals 17.8. Now, the answer, the instructions say leave your answer in simplest, as radicals in simplest form. Well, that answer is not going to be a radical. So it doesn't exist as a radical, so you're good. Now this one's interesting. It says, if the cosine of d equals 24 over 25, find the following. We'll find the sine of angle d. Well, I can't do that because I don't know what angle d is, but I have enough information to figure it out. So I can do an inverse function. So if the cosine of d equals 24 over 25, then the actual measurement of angle d will be the inverse cosine of 24 over 25. So I pick up my calculator, I go second cosine, I type in 24 divided by 25, and I get 16.26, which is going to round to 16 degrees. And so now I can come back here and find the sine of 16. I can find the tangent of 16. I can find, oh, the sine of f. Well, wait a minute, where did f come from? So let's see, this is 16. Remember, f is the complement of 16. F is the complement of 16. So what would the complement of that be? Remember, complementary angles add up to 90. So if I go 90 minus 16, then I will get the complement. So the complement is 74 degrees. So now I can do these. So this is the sine of 74 degrees, and this is the cosine of 74 degrees. And so let's come back and do the math. So the sine of 16 is 0.2756. Okay, the tangent of 16 is 0.2867. The sine of 74 now is going to be 0.9613. And the cosine of 74 is going to be 0.2756. All right? All right. So now let's look at number 14. Hey, we're almost done. Yay. Change colors here. So it says write an equivalent trig ratio. So this is the one where we had the half sheet of paper and we learned about the complementary angles. And so we would say here that the sine of 60 equals the cosine of the complement. 90 minus 80 equals 10. So this would be the cosine of 10. You're done. That's all you have to do. So this one starts with cosine, so I know it's going to be the sine of something. So 90 minus 37 is 53. So that would be the sine of 53. And hey, look, guys, use the calculator. Don't do, I think I wrote this wrong, sorry. Don't do stuff in your head because your brains will sometimes play little tricks on you, okay? And so just be safe. Use the calculator or do it in your head and then check yourself on the calculator. So again, what was the rule? How did we come up with this number here and this number here? We subtracted the original angle that we got given from 90. So let's just follow the pattern. 90 take away 2x is just 90 take away 2x. So this is going to be the cosine of 90 take away 2x. So whatever is here for the angle, if you subtract it from 90, that will give you the complement. I'm so happy because we're almost done. Now, solving a right triangle, it means find all missing measurements, all of them. That means all of the missing angle measurements, and then all of the missing sides. So I know this angle, and this angle right here is going to be the complement of 34 degrees. So I can go 90 minus 34, and I get 56. So this angle is 56 degrees. And then it says find the length of QR. So I'm just going to use this angle right here. So QR would be the opposite side, and this would be the adjacent side. So I'm going to do a tangent function. So the tangent of 34 degrees equals the length of the opposite side, which is my unknown, x, divided by the length of the adjacent side, which is 11. And so x is on top, so I multiply. X is going to equal 11 times the tangent of 34. I pick up my calculator. 11 times the tangent of 34. Close my parentheses, and I get x equals 7.4. So I'm going to come over here and 7.4. And then the last question says find the length of PR. So now my labels are going to change a little bit. So now my x is here, 34 is here, this is the hypotenuse. This is still the adjacent side because I'm still in the same spot. And what trig function is that? That's the cosine function. Oh, yeah, that's the cosine function. Sorry, for a second I had to stop and think. The cosine of 34 degrees equals the length of the adjacent side, 11, divided by the length of the hypotenuse, x. X is on the bottom, which means I divide. So I rewrite this as x equals 11, draw a little line here, over the cosine of 34 degrees. Remember, we switch and divide, switch and divide. Pick up my calculator. I type the top number in first, always, when you're typing in a fraction like that. 11 divided by the cosine of 34, close off my parentheses, and I get 13.3. And we are done. Let me fix this, make it a little clearer. 13.3. Awesome. I hope this helps. Have fun studying. Remember, tomorrow, quiz time. Bye-bye. Bye-bye.